What is slope-intercept form? Y equals mx plus b. What does the m stand for? Slope. What does the b stand for? The y-intercept. What is point slope form? Y minus y1 equals m quantity x minus x1. Where x1, y1 is a point through your line, and m is your slope still. So any slope and any point. What about our general form or standard form? It's not one we use as frequently. AX plus BY equals C. With standard form, we want whole numbers only. I was going to say, and you're partially right on there. A needs to be positive. We cannot make that claim about any other number. Everything else could be negative, but A has to be positive for it to be in standard form. The number with my x needs to be positive. X and y, whole numbers only, and A has to be positive. So no fractions and all that jazz. And we're going to work with all three of these today. We're going to start with remembering graphing lines. Fairly quickly, we're going to do 3 sets of lines. So before I get there, I'm going to make sure we get this written down. So I'm going to pass out some graphs. We're going to do a set of lines on each of these graphs. And when I say a set of lines, it means I'm going to give you something like this. We're going to do a sketch for y equals mx with these 3 different m's. So we're going to do 3 graphs, and on each graph, I believe we're putting 3 lines. Just to help us remember graphing lines and all that jazz. Okay, so we're going to sketch the equations for y equals mx using these 3 different m's. So first things first, when we're looking at this, what form is this kind of in?
Slope.
Yeah, it's kind of in our slope-intercept, right? But what's my b? 0. So my b is 0 for all of these. So when they say m equals 4, what we're really graphing is the line y equals 4 is going in place of that m. So we have 4x plus 0. So when we're graphing this, where are we going to start? 0. That's my y-intercept. My y-intercept is at 0. How do I move with my slope of 4?
So
Up 4 and 1 to the right. 1, 2, 3, 4, 1 to the right. Up 1, 2, 3, 4, 1 to the right. my graph is a little bit bigger than you guys, so I think you can only fit one dot. I could also go down and to the left for a positive 4. Down 1, 2, 3, 4, and to the left 1. Down 1, 2, 3, 4, to the left 1. Connect these up using a ruler. Whenever you graph a line, you need to use a ruler. Yes, I can tell. So connect up your points, as many as you can fit on your graph. Go from edge to edge on the graph we give you. And draw your arrow. What's up? So this was green. Questions on that? These two. Correct. Yeah, we're going to do all 3 of these on the same graph because I'm going to have another set of us for the next graph and another set of them for the last graph. Okay? So don't do all 3 on different graphs. We're doing all 3 of these on the same graph. Otherwise, it's going to take you 9 graphs to get through what we sketched in today. Same graph. Now we're going to do m equals negative 2. What's my equation for this one? Y equals negative 2x. Still plus 0. Mm-hmm. Yeah, so the only thing different on this is my slope. Instead of going up 4, right 1, we're going to go down 2, right 1. Still has that y-intercept at 0. So down 2, right 1. Down 2, right 1. As many points as you can until you fill up your graph. My graph's a little bit bigger than yours. I can also go from my y-intercept at 0 and go up to left 1. That is absolutely valid. As long as I switch them both, that's totally fine. Again, whenever we're graphing lines, connect them up using a ruler or a straight edge of some sort. And our last one up here. What's my equation for this one?
Y equals
1/2 x plus 0. You don't have to put the plus 0, but if that helps you, absolutely put it there. Totally fine. How do I move with that slope? Up 1, right 2. Up 1, right 2. Up 1, right 2. Rise over run. Rise of 1, run of 2. This should be familiar. We have graphed from slope-intercept form since like 5th grade, 6th grade. We've started graphing with slope-intercept form way back in the day. I'm pretty sure my 5th graders could graph lines.
Our education system
In the 5th grade curriculum. However, I'm not saying we remember it that long ago. But we've seen it lots and lots of times. Okay, questions on our mx plus b kind of vibe?
I remember fraction and what the key was.
Okay. So the next one I'm going to give you, it's very, very similar. New graph. Now I'm giving you a point and some slopes. So we're going to have the point 3, 1. So point P is going to be 3, 1. So I'm just going to plot that point right here. So 3, 1. And we're going to write the equation. If I have a point and I have a slope, we should probably use point-slope form. Our point-slope form, that's when we have, I'll just put it on the same screen, that's our y minus y1 equals mx minus x1. So if I was to write this first one, m of 0 in an equation, I have an m, so I have a slope, and I have a point. I can write the equation here.
0 minus 0.
Ooh, leave your letters. Y minus the y value from my point.
Oh.
Y minus 1 equals our slope 0 times x minus the x value from our point, 3. So that's how we would write our equation. And we can leave it like that. It's in point slope form. It's a form. We can leave it like that. You can also simplify it if you really want to. Because what's this going to look like? More specific, because all we've done so far is straight lines today. What does a slope of 0 look like? I was like, they're all lines. Specifically, what kind of line? A horizontal line. I was going to say, because technically these are all lines. They're all straight lines.
Yeah, but I meant horizontal.
Ah, you got to be specific. So it's a horizontal line. My slope is 0. When in doubt, you can still do your rise over run. Rise of 0 over 1. Up 0 over 1. Up 0 over 1. Up 0 over 1. It's going to give us a horizontal line. Up 0, left 1. Up 0, left 1. So you can do it that way too. So m of 0 gives us a horizontal line. A horizontal line. The other two are very much straightforward. That's like kind of the weird one I throw at you on this one. So our next one, we have an m of 2. I'm going to write my equation, and we're going to graph it. So in our point slope form, we're writing this as our y minus the y value from our point, 1, equals my slope of 2 times the quantity, x minus 3. And you can leave it like that. You don't have to put it into slope-intercept form. If you want to, you absolutely can. But we can work with this. We're starting at our same point, 3, 1. So still starting at this pink point here. And we're going to move with a slope of 2. How do I move with a slope of 2? Up 2, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. Or down 2, left 1. Down 2, left 1. As long as I switch them both, I can do whatever the heck I want. The more points you draw, the easier it is to connect them up with your ruler. If you just draw like 2 points, like if you just draw the pink point and this one, it's really hard to get your line to line up correctly. So the more points you draw, the easier it is to get your line in the right spot. Last one like this, what's my equation going to be for this purple one? Y minus 1 equals negative 1/5 x minus 3. So it's still going through that same point. Still starting at that pink point. And if you guys ever want colors to do stuff, like I seriously have giant boxes of color pencils in there if you need them. I can always make you guys colors. How am I going to move from that pink point for this purple line? How do I find my next point? Down 1, right 5. Down 1, right 5. 1, 2, 3, 4, 5, which I believe is off your guys' graph. So you're going to have to go up 1 and left 5. 1, 2, 3, 4, 5. As long as I switch both, it still gives me a downward slope. Don't poke people with my rulers. Again, the more points we have, the easier it is to connect it up properly. But it should look like that. So point and slope works pretty good for point slope line. We don't always make things easy though.
Okay.
Yep, I'll go back. So these all went through that same point and had slopes. So sometimes we're just drawing things through these. And there are homework questions just like these. Okay. All right. Ready? So now we're giving you 3 equations. Got a little bit of everything going on here. So we've got y equals 2x plus 1 as one equation. 2x minus 5y equals 8. And y minus 2 equals 1/2 x plus 1. 3 different forms here. We can use whatever techniques we want. So A is going to feel very familiar. We are used to graphing things like this a lot. How are we going to graph this one? Where are we starting? 1. My y-intercept of positive 1, so the point 0, 1. Up 2, right 1. So this one's in our slope-intercept form. Or we can go down to left 1 and flip the sign on both. Should look like that. When you are drawing graphs, please give me lines. Like if you have windows like this, go to the edges. If you're drawing it on graph paper, give me a decent amount of length. If you just give me a line like this, that's not going to count. That does not count as a line. I will have someone do it, I guarantee it. Every year I do. And every year I usually have a couple. Do not draw teeny tiny little baby lines. Give me a line. Do not do teeny tiny baby lines. Give me big kid lines for big kids. All right. Which one do you want to do next, B or C?
C.
C. I was going to say C is really familiar to what we were just doing. So let's look at C first, and then we'll come back to B. Yeah, so we can find the point that's in here. Usually it's x minus the x value from our point. So our x value is -1. And our y is usually y minus y1. So it's -1 comma what? 2. And what's my slope?
2. Wait, 1 over 2.
1 over 2. 1/2.
Mm-hmm.
So my starting point is at our -1, 2. So right there. And we have our up 1 over 2. Up 1 over 2. Up 1 over 2. Or down 1, left 2. Down 1, left 2. that one is C. This one is A. And let's figure out what the heck we can do for B. We have lots and lots of options for how to approach B. You could do XY intercepts, where we substitute in 0 for X and then 0 for Y to find our intercepts. You could solve this into slope-intercept form and do it that way. You could do a guess and check method, but that takes the absolute longest amount of time. So you can go any direction you want to. When we're in standard form, I do feel like sometimes our XY intercepts are the easier way to go. They might wind up fractioning and gross, but we can do it. Or you can go slope-intercept form. Either way is fine. I think XY intercepts probably is the easier way to go. So to find our X and Y intercepts, we know our X intercepts come in the form X comma 0, right? So I know my Y has to equal 0. So if we substitute in 0 for Y, 2x minus 5 times 0, we have 2x equals 8, right? So what's our X-intercept? 4. So it's the point 4 comma 0. So that one's not too bad, substituting in 0 for Y. To find my Y-intercept, we know that's 0 comma something. So if I substitute in 0 for X, 2 times 0 is 0. So we have negative 5Y equals 8. So what's my Y-intercept? Careful. Negative 8/5.
Wait, why did we have these topics? I remember learning that simple method. We had to like.
X and Y intercepts? You did.
No, we did, but like just to substitute in 0 to 5.
Mm-hmm.
The Y.
Sometimes this is taught as like the cover-up method, like that. So our X and Y intercepts, we have 4, 0. And we have negative 8/5. About, what is that? Decimally. Yeah, negative 1.6-ish, because it would be 3/5 left, which would be 6/10. So negative 1.6, so a little bit over 1.5. Negative. When we do X and Y intercepts, that is where we are the most sketch-like as far as our images go, because we can only do 2. That is a very skinny line. You can always pick more X values to substitute in to get pieces on your graph to get more points. That's B. You could also solve this into slope-intercept form. We would get 2/5 X minus 8/5. So we'd still be starting from a weird decimal-y Y-intercept. But we can do that. Okay, questions on the graphing part of this? Okay, because we're going to be done graphing. Like, we're not going to be doing more graphs. But we're still going to keep talking, so we got more stuff to talk about with lines. Because the book is going to ask you all kinds of weird questions about lines. But a lot of these we have talked about before, but I want us to be able to practice it. So we've talked about slope before. Finding a slope between 2 lines. Or between 2 points. What's up?
Okay, so this is negative 8/5, right?
Mm-hmm.
So when do we go? How when is that work?
Where's 4, 0?
Oh,
Yes,
so-
there you go.
oh, okay.
There you go.
Thank you.
Yep. No, 100%. I knew exactly where the sticking point was. You just had them like in your brain. You were switching the 0 and the 4. Okay. So I'm going to give you 2 points, and you're going to find the slope. How do I find the slope again? We talked about it. That's the change in our y's over the change in our x's. So if you've done physics, you've seen the triangle thing. It is a math thing. It's called a delta. It's change. It just means change. So another word for change is our difference. So we're going to find the difference in our y's. So we typically do y2 minus y1 over x2 minus x1. The most important piece is that whichever point you pick to be 2, they match up. And whichever point you pick to be 1, they match up. It does not matter which one you have as point 1 and which one you have as point 2. It does not matter. Just make sure that you do not do crisscross, or you will wind up with the wrong sign. So which one do you want to have be point 2? C or D? C. I'm doing C is point 2, which makes by default D be my point 1. So when I'm setting this up, we're finding the difference between the y's, so 2 minus negative 7, which becomes 2 plus 7, and the difference in my x's. So my x is negative 3 minus negative 9, so it becomes negative 3 plus 9. So what is my numerator? Positive 9. What's my denominator? Positive 6. So what's my slope? Simplify it. Fraction. 3 over 2. We can leave them as improper fractions. That's totally fine. That's way easier to do, especially graphically, than a decimal. Bless you. These bottom two pieces of information here, we worked with already once. We used them when we were talking about our right triangles, when we talked about our parallelograms from like day 1. Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal. So upside down and the other side. Meaning they have a product of negative 1. That's what it means for them to be opposite reciprocals. So we're going to use that in some of the kinds of problems that they give us in the homework, where they're going to give us information about a line and we're going to have to write an equation that meets the requirements. So a lot of what this is that makes this different from what we did at the beginning is we're doing a lot of backwards work. They're going to be giving us pieces and we're building the equations. Yeah. Okay. Let me see. All right, let's get things written down. Still see several people writing, so I'm going to keep that time. Yeah, we have it. We're good on time. Okay. So we're going to find the general form of an equation that goes through point A and meets this equation, so, meets this condition. So we have 3 equations we're going to write here. So I've got an A of 5, negative 2. So these are all going through that same point A. But they have different rules for them. So when in doubt on something like this, if they're giving you a visual and you are a visual person, sketch it out. So I'm just going to give us a really quick, oh, that was a trash line. There we go. So 5, negative 2 is somewhere down here. So it needs to go through that point. And I also need it to be parallel to the y-axis. So what is that going to look like? Wisconsin came out on that, so a little hard. So, don't you know? What's that going to look like? It's going to be a vertical line. If it is parallel to the y-axis, that means they have the same slope, and it's going to be a vertical line. How do we write the equations for vertical line? X equals. Because what's my slope here?
5.
I was going to say not 0. 0 is when it goes straight sideways,
So
right?
1.
What does this rise? 1. How many over did it go? 0. 1 over 0. What's my slope? Can I divide by 0?
So 0.
Undefined. Vertical lines have an undefined slope. I can't divide by 0. It breaks all the math rules. Undefined slope. That is not our final answer. We still have to write the equation. Since it's undefined, I can't have a y equals. That's what that means. My x is stuck, is locked. What is my x locked at here? 5. X equals 5 is a vertical line. X equals 2 is a vertical line. X equals negative 12 is a vertical line. But the one that goes through 5, negative 2 is the one that also goes through 5, 3, is the one that also goes through 5, 100. My x is stuck at 5. You see that? Let's look at this next one. Now it's going through that same point, but it is perpendicular to the y-axis. So it's still going through this point, but what's it going to look like if it's perpendicular to the y-axis? A horizontal line this time. Because it's going to look like this. Perpendicular means it's got a right angle right there. What's my slope of a horizontal line? 0. So it's not undefined. I go up 0 over 1. Up 0 over 1. Up 0 over 1. I can do that. So my m on this one equals 0. On my blue is when we had an undefined slope. Vertical lines have an undefined slope. Horizontal lines have a slope of 0. So what is my equation going to be here? Y equals what? Negative 2. Or you can put 0x minus 2. That's absolutely valid. Last one's going to feel a whole lot more normal. So I've got my point A and a slope of negative 4. How can we build an equation for this? Yeah. Y minus the y value for my point. So y minus negative 2 becomes y plus 2 equals our slope of negative 4 x minus 5. So that's in point slope form. But they said at the very top to put it in general form. So we are going to scooch this one around. The other two, since they didn't have any coefficients, they didn't have any decimals, we didn't need to change anything. But this one we do. So I need to get my x and y on the same side, constants on the other, and make sure that my x has a positive value. So what do we need to do here to get this to be in general form? Distribute first. So I'm going to have my y plus 2 equals negative 4x. Ooh, careful. What sign? Plus 20. Then what are we going to do? I need my x's and y's on the same side. If I want to wind up with a positive x value anyway, what should we do with my negative 4x? Add the 4x. That's going to be easier for us. It's going to make us have less work. I want to get my x positive, so I'm going to move my x so it's positive. What else do we need to do? Subtract the 2 from both sides. So this will give us my positive 4x plus y equals what? 18. So that's what they mean by general form. We're going to do another set. I know, I'm horribly cruel. So again, we're going to try and write these in general form. I've got a point A, and I have a condition. So I know it's going to go through point A, and it's going to go through the point 3, 1. So it's going to go through negative 2, 4, and it's going to go through 3, 1. So I know 2 points that this line is going to go through. What do we need to find? Slope. I need my slope. How are we going to find our slope? The difference in the y's over the difference in the x's. The change in the y over the change in the x. That's how we find our slope. So what are we going to do? Ooh, careful, careful. You've mixed your x's and y's. 1 minus negative 4, or 1 plus 4, over what? 3 minus negative 2, or plus 2. So we get in our numerator what? 5 over 5. So what's my slope? 1. So now I need to write this as an equation. And you can use either one of your points. It does not matter. So what will we get when we write this as an equation? Y plus 4 equals
1.
Yeah, so you can either put our 1 x plus 2, or we can notice that we don't actually need that 1 and get my y plus 4 equals x plus 2. So I need to get this into standard form, meaning I need my x and y's on the same side, numbers on the other, and x needs to be positive. So subtract y and subtract 2. So we get, on the right-hand side, I'm getting x minus y, and on the left-hand side, I have 2. So 2 equals x minus y, or x minus y equals 2. Either way, but my... Hello? No one touched anything. You're fine. Okay, this next one tends to be the ones that kind of throw us off. I've got A through the same point, and then parallel to 5x minus 2y equals 4. What does it mean for them to be parallel? Same slope. How can I find the slope of this guy? Put it in this, yeah. Put it into slope-intercept form. Get the y by itself. What do I need to do to get the y by itself? Minus 5x. So I have negative 2y equals negative 5x plus 4. How do I get the y by itself? Divide by negative 2. And we get 5 halves x minus 2. So what's my slope? 5/2. So what is the slope we're going to use for this line? 5/2. When we're looking at the perpendicular, just because I don't want us to run out of time, what do we need to change about our slope? Opposite reciprocal. So this is using that same line. So on B here, we're going to use our slope of 5/2. And on this third one, we're going to use our slope of the opposite reciprocal. So upside down, 2/5, and with the opposite sign. So we'll do the same exact thing we would do in the first one, but we're also like short on time, so I'm not going to like sit here and do the whole thing. But we can do that. We've got a slope, I've got a point, we can put it through point slope form, we can multiply it out into general form. What's up? Because it is perpendicular, it's this same equation here, so I took this slope and we did our upside down opposite sign. Okay, it's the same equation. So it's the same original slope, and to make it perpendicular, you do our opposite reciprocal. Have a great rest of your day, even though it's Monday. Everybody have to think this is homework 3's numbers. They're not super long. I know it looks like a lot of questions. They're not super long questions.